Hello. In this session, we are going to discuss about representation and notations used in IPv4 addressing, IPv4 classes and their address range. IPv4 is Internet Protocol version 4, which is used at the network layer of TCP/IP protocol stack. Unlike MAC addresses, IP addresses are called as logical addresses because they are not assigned or associated with specific hardware or the physical device. They are assigned or allocated to the whole system. IP addresses are used by routers for routing purpose for communication between the hosts. Now, during the communication between two hosts or two users, source or destination IP do not change. Now let us have a look at the representation. IPv4 address is 32 bits long, that is 4 bytes long. So total number of IP addresses available with us are 2 raised to 32. Though this number seems sufficient enough, still due to increasing demand of IP addresses for assigning to the various gadgets or various machines, we will soon be migrating from IPv4 to IPv6, that is version 6. Still, we are using IPv4 addresses. We have not completely migrated yet, though that is why it is important for us to understand how IPv4 addresses operate, how are they represented, and how they are assigned. 32 bits of IPv4 addresses have 4 fields. Each field corresponds to each byte, and obviously each byte will have 8 bits in it. Those 4 bytes are separated by a dot as shown on your screens. Each byte is shown with a different color, and all the bytes are separated by a dot. Each field is then converted to its corresponding decimal value, and that is why the IPv4 representation is known as dotted decimal representation. Let us have a look at the dotted decimal representation. The same IP address is visible in front of your screen, on your screens. Each byte is represented with a different color, and all the bytes are separated by a dot. Now, once we have 4 different fields, each field is then converted to its corresponding decimal value. As you can see, first byte, that is 10001100, corresponds to 140 in decimal. Similarly, we have all 4 bytes converted to decimal number. And then finally, these decimal numbers are represented in a specific format where these numbers are separated by a dot. So finally, the IP address that we come up with is 140.27.50.241. And this is why the notation is known as dotted decimal notation. Each byte is represented by a decimal number, and all the bytes are separated by a dot. In an IP address, there are 2 fields, 2 parts. One represents the network that IP address belongs to. So higher order bits from left side, higher order bits are known to be network ID bits, and right side to the network ID we have lower order bits of IP address, and those are known as host ID bits. Now, how many bits for network ID and how many bits are assigned to host ID, that depends on how much range of IP addresses that organization wants to reserve. Now, for this, let me give an example. Suppose we have an organization where we need to assign 8 hosts, or we will take example of 6 hosts. So, to assign IP addresses to 6 hosts, 3 bits are sufficient because 2 raised to 3 is 8. So if you reserve 3 bits to represent the hosts, then rest of the 29 bits will be representing network ID portion. Similarly, if we take an example of an organization where 1000 employees work and the employer wants to assign a single PC or a single host with a specific or unique IP address. In that case, 1000 IP addresses will be required for 1000 hosts, and that is why in IP address 10 bits will be reserved for hosts because 2 raised to 10 is 1024. So reserving 10 bits would suffice the purpose, and that is why in this example 10 bits will be representing host ID portion and rest 22 bits will be representing network ID portion. We always need to remember that network ID portion is the higher order bits, that is from left side, and rest of the bits, host ID bits, are at the right side of the network ID, which are lower order bits from the IP address. Now these IP address ranges, we took an example of an organizations, two organizations. So employers of those organizations, owners of those organizations have to reserve or purchase the IP address ranges, and those IP address ranges have to be registered with a specific registry, and that registry is known as RIN, that is Registry for Internet Numbers. These registries are operating differently for various countries, and Indian registry is called as IRIN, Indian Registry for Internet Names and Numbers. So how much ever address range the employer wants to reserve, that should be reserved and registered to IRIN. This is the representation of net ID and host ID portion. One more additional parameter you can see on your screens here. Leftmost side of your IP address represents class type. That means we have various classes of IP addresses, and so this addressing is known as class full addressing. There are two types of addressing, class full as well as classless. Currently we are discussing class full addressing, where IP addresses belong to a specific class or category. Now why do we need classes? We saw the examples of two organizations. In one organization, 6 hosts were there, and in second organization, 1000 hosts were there. Now let us have a look at the diagram on your screens, and then we will come back to the same example. In class A, there are 5 classes, class A, B, C, D and E, out of which class A, B and C are operating classes, whereas class D IP addresses are used for multicasting. Multicasting is nothing but group messaging. So if we know broadcasting is one to all, unicasting is one to one, and multicasting is one to many. So these many people, like group of people, can be addressed with the help of a single address, and that address is known as a group address. So class D IP addresses are used for these group messaging or group addressing. So we have class D assigned to multicasting. Similarly, class E IP addresses are not used. They are reserved for future use or research purpose. So right now we are interested in operating classes, that is class A, B and C. And how are they defined? How are they differentiated? They are differentiated depending on how many bits belong to network ID portion and how many bits belong to the host ID portion. In class A, we have first 8 bits that are assigned to network ID. You can see it on your screens also. And rest 24 bits belong to the host ID. So 1 byte and 3 bytes is the division for class A. For class B, 2 bytes assigned for, that is 16 bits assigned for network ID. Rest 16 bits, that are 2 bytes assigned for host ID portion. And for class C, we have 24 bits, that is 3 bytes assigned for network ID and 1 byte, that is 8 bits for host ID. You also can observe that the class type that we have seen on this slide is evident or visible for every class. For class A address, all the addresses that belong to class A will start from binary bit 0. Similarly, class B addresses will start from 10, class C from 110, class D from 1110 and 1111 for class E. So depending on first few bits in an IP address, you can identify the class. Now let us come back to our example of two organizations. First organization with 6 hosts. Now looking at the diagram, what do you think? Which class that organization should belong to? Certainly it should belong to class C, because in class C, number of host ID bits are 8. Similarly, second organization where 1000 hosts are available. For this, we need to have class B IP address, because now we need 10 bits to be reserved and here we have 16 bits reserved. So future expansion of the organization is also taken into consideration by the employers when they reserve the IP address ranges. So this is why the IP addresses are classified into 5 classes. Let us just rewind what we discussed. 3 operating classes A, B and C. Class D is used for multicasting. Class E is used for reserved for future use or used for research purpose. Differentiation between class A, B and C is based on number of bytes that are assigned to network ID and host ID portion. That also we can see on this next slide. So for class A, this is just the consolidation of what we discussed on the previous slide. And one more thing to notice here is the starting bit or number of bits that are specifically assigned to each class. In this table, the last column belongs to total number of available hosts. So if for class A, number of host ID bits available are 24, and that is why 2 raised to 24 hosts can be entertained, can be assigned with IP addresses that belong to class A. Similarly, number of available hosts can be 2 raised to 16 for class B and 2 raised to 8 for class C. All this can be calculated just by remembering how many host ID bits are used for that specific class. Here we have ranges of IP address classes. So for class A, we have range 0000 to 127.255.255.255. Now let me give an example how these IP address ranges are formed. For class A IP address range, obviously the starting bit must be 0 for class A, because class type is 0 for class A. Apart from this bit, the first address from the class A will have all zeros, right? So now dot this is the first address of class A, and the last address of class A would be, now the first bit is fixed 0 because it belongs to class A. First bit will remain as it is, and this is the last address of your class A. So all the binary bits would be ones. Sorry. So this is the range for class A. Now if you convert this number into decimal, this is going to be 0.0.0.0, and if you just convert this into decimal using your calculators, you will get to see that first byte is 127 and rest 3 bytes are all ones, that is 255. And this is how range of IP address can be calculated. Similarly, if we consider the example of class B IP addresses start from 10. And so, instead of having 0 as the first bit, we have 10 as the first 2 bits, and then rest of the bits will be zeros for first address, and last address would be 10 fixed and rest of the numbers would be ones. Now if you convert this into decimal number, you will get to see that the number is 128.0.0.0 to 191.255.255.255. So this is how you can calculate address range of any IP address class. So you can have a look at this ranges of IP addresses where the network ID portion is shown in green color so as to differentiate for various class, and then you can take a look at the address ranges that are calculated. We also have seen the example how the IP address ranges can be calculated from the class type. Now let us have a look at the questions. So identify the class of given IP addresses. For identifying the class, there are two methods. First method obviously is looking at the first byte. So 0 to 127, the IP address will fall into class A. From 128 to 191, the IP address will fall into class B. Similarly, for class C, 192 to 223, 224 to 239 for class D, and 240 to 255 for class E. So this is the way, just by looking at the first byte of the IP address, it can very well be understood which class that IP address belongs to. So you just can find out which IP address classes these addresses belong to. The same method can be used for these examples, and for last two examples, either you need to convert this whole thing in decimal and then check range that it falls into, or otherwise just check the first few bits and then you will get to know which class type it belongs to. If the first bit is 0, then it is class A. First two bits are 1, 0, class B, and so on. Right? So this is the right way of converting or identifying the IP address classes. So in today's session, we have discussed about the representation of IP addresses, 32-bit IP addresses represented in dotted decimal notation. Each byte is represented with a separate decimal number separated by a dot. Then we have seen IP address classes, class A, B, C, D and E. D is used for multicasting, E is used for future use, E is reserved for future use. Operating classes are A, B and C, and these are differentiated based on number of bits reserved for network ID, and rest of the bits will be reserved for host ID portion. So for class A, the differentiation between net and host ID bits is 824. For B, it is 1616, and for C, it is 24/8. So here we come to an end of this session. Thank you.